Okay, we're going to learn how to calculate mass percent of water for a hydrated compound lab. So basically, there are two ways to calculate mass percent of water for any compound. If you have the chemical formula, you can use the theoretical method. Basically, just use the molar mass of the compounds and you will be able to figure out the mass percent of water. That is a theoretical way. Okay, now if you have an unknown and you don't know what the formula is, you'll have to do an experiment to calculate the mass percent of water, which is what we'll be trying to do here. And then you'll get to calculate the mass percent of water experimentally. So the goal of this lab is basically you have a few knowns. These are your options for your answers. I'll show you how to do the first one, which is BaCl2 2H2O. This is barium chloride dihydrate. So basically there's two waters here and we'll try to calculate mass percent of water for this compound. There are also other choices on your unknown, your known choices. You have calcium chloride dihydrate, magnesium sulfate heptahydrate, zinc sulfate heptahydrate, and then of course the last one you have your sodium carbonate decahydrate. Okay, so you will have to calculate these on your own, but I'll show you the first one. So hopefully you figure out how to do it. And then once you get all the known or theoretical mass percent of water, each one will have a number. What you do is you take your data. Again, this data is different than what you are provided, so please do not copy these numbers, but it's just to show you how we can do the calculations. So I'm going to do the math over here, and we'll see this mass percent here will match one of these guys. The one that matches will be the answer, basically. Okay? So I'm only going to show you one example of a known, and I'll show you how to do the unknown. So let's go ahead and get started. So for the theoretical value, basically, I need to know barium. For an periodic table, you get the molar mass of barium, get the molar mass of chlorine, and then for water is 18.02. There's two waters, so I'll multiply that by 2. Chlorine, I'll multiply that by 2 because there's 2 chlorine, and there's only 1 barium, so I'll multiply by 1. So these three numbers here should give you the molar mass of this hydrated compound. Okay, so when I add it on the calculator, the molar mass of BaCl2.2H2O. So let me go ahead and put this in my calculator. 137.33 plus 70.9 plus 36.04. And this should really be 90 over here, okay? All right, I got 244.27 grams per mole. Now, to get mass percent of water, all you take is mass of water. So mass of water over mass of everything, the sample, times 100. Okay, so the mass of water in this sample, we're assuming we have 1 mole, so we're using molar mass because molar mass is grams per 1 mole. So we're saying the whole sample is 1 mole, so the mass of 1 mole of the sample is 244.27 grams. Okay, and 1 mole of this compound, I will have 2 moles of water, which means it will be this many grams of water, 36.04 grams of water. Okay, and I'll take that times 100, I will get the mass percent. In this case, I have 4 sig figs and 5 sig figs. I will keep 4 in my answer. So I will take 36.04 divided by the value that I just got earlier times 100. And I get 14 point, see the long list of numbers here? I'm just going to keep 4, so 14.75 mass percent. So that's how you would calculate the known value. If you have the formula, just assume you have 1 mole of the compound. You'll take mass of the water divided the mass of the sample of 1 mole. So 1 mole of the compound, which is the molar mass, mass of the water, which would be 2 moles of water, because it's 2 in the formula here. So you put this together, okay? Now, let's keep going now to do the unknown here. For the unknown, the values given here, basically you'll have the empty crucible, and then the crucible with the hydrated compound, which has water, and then you start drying it. The reason why they didn't do the third heating for this case is because you can see between the first and second heating, there is basically no change. In fact, due to experimental error, there's a little bit increase, but it's not significant enough. What they're looking for is basically we don't want it to drop more than 0.05 grams between the first and the second heating. If you didn't do a good job heating it on the first go around, the second heating would have dropped a lot because you removed even more water in second heating. But if you did a really good job during the first heating, the second heating basically is just ineffective. You don't really need to do it because it's already done, so you see the numbers are the same. Now, if the second heating number dropped, you would have had to do a third heating. In this case, we didn't have to, okay? So what I'm gonna do is we're just gonna use the number for second heating for the last heating and to do the last heating step, okay? So mass of hydrated salt would be the mass of the crucible and the cover in hydrated salt minus the mass of the empty crucible. So that would be, in this case, 23.4596 grams minus 22.2519 grams. Notice I have 4 decimal places here. When I subtract, I will also have to keep 4 decimal places. So 23.4569 minus 22.2519. Okay, let's go ahead and do that. I get 1.205, never mind. 1.20. Now, again, did I type something wrong? Yes, I did. Oh, forget that. Let's type it again. 23.4596 minus 22.2519. 1.2077. I have 4 decimal places, which is great. And then we will want to do the mass of anhydrous salt after last heating. So after the last heating, I'll just take this value here. That is pretty much almost the same. I'll just take the second heating and take the second heating minus the empty crucible. So I'll get the dry stuff, the anhydrous, okay? So I'll basically need 22.8578 grams minus 22.2519 grams. So let's see what that gives us. 22.85778 minus 22.2519. So I get 0.6059 grams. Okay, which is good because I have 4 decimal places. 4 decimal, I should keep 4 decimal places. Now that I have these two numbers here, I need to calculate mass of water loss. So basically, mass of water loss would be the difference between the hydrated and the anhydrous. So you just take 1.2077 minus 0.6059, okay? (0.6018). Okay, so that's the mass of water loss. If you have the mass of water loss, you essentially already got the water component of your sample, and your hydrated salt would have to be the total of your sample. So to get the mass percent of water, you take 0.6018 grams, because that's the mass of water, divided by the total sample when it's wet, because it has water in it, will be 1.2077 grams times 100. And this will give you your percent. So 0.6018 divided by 1.2077 times 100, I will get 49.83. So I keep 49.83 because there's 4 suffix and there's 5. I will keep 4. So in this case, my answer is 49.83, which doesn't match the first one. The first one for barium chloride dihydrate is 14.75. So I probably match one of these later, guys, here. You'll just have to do the calculations on these guys to see which one matches. Hopefully this helps. This is just one trial. In your lab, you will have two trials, and your answers will be different set of data.